derivative stuff, we learn how to do a different type of derivative, a more advanced derivative. We learn about other things we can do to apply it, and then we learn about finding tangent lines with that type of derivative. So we've seen tangent lines before. We have a general idea of how they work, right? And they don't go away for this test, so you definitely need to know how to solve them. So reminders about tangent lines: they model instantaneous rate of change at a point on the curve. They are linear equations, and they can be found using the point-slope formula. That formula right there, you will need to know that for the test. I will not provide it for you, so make sure you know it by memory. And m represents the derivative evaluated at the exact x value. So you always got to start by taking the derivative, and then depending on what type of question I'm asking you, we go from there. So step 1, it says find the equation of the tangent and normal line to the point 1, -1. So step 1 is we want to rewrite our equation in a way that we don't have that in the denominator anymore when possible. You could, of course, use the quotient rule, but you want to avoid using the quotient rule whenever possible because it's a little bit harder, right? So I rewrite my function in this way. So now I can use what rule?
Product rule.
Not the product rule, the chain rule, because the power, right? So my outer, I take the derivative of the outside times the derivative of the inside. What's going to happen with the exponent here?
You're going to drop it down and it's going to go to -4.
Good. Bring your exponent out front, you subtract 1 from your current exponent, so that becomes -4. And then I multiply this all by what?
2.
Not 2, but
-2.
good. The derivative of the inside, the constant goes away, the -2x becomes -2. So from here, you should be able to simplify this down to 6 all over 1 minus 2x to the 4th. That's its most simplified form. And now that we have the derivative, let's see what the question's asking for. It wants to know the equation of the tangent and normal line. So we know that in order to find that equation, we need to know the slope, right? So to find the slope at that given point, we have to plug my x value into the derivative equation. So that's going to be y prime equals 6 over 1 minus -2 times 1 to the 4th, which is going to be -1 to the 4th, which is 1. 6 divided by 1 is just 6. So this is my slope of my tangent line. That's the slope of the tangent line. We also need to know the slope of the normal line, which would be what? If the slope of my tangent line is 6.
Would it be 1/6?
Not 1/6, -1/6. So the slope of my normal line is -1/6. So the question wants us to find both of those equations. Now, next thing we want to confirm is, you notice, did they give us the y value this time?
Yeah.
Yeah, that saves us a step of plugging it back into the original function to obtain it, right? So we don't have to do that here. So now we can just go ahead and start finding the tangent line, which is going to be y minus y1, which becomes a plus, equals m times x minus x1. So everybody understand where I got those numbers from? Okay. I distribute, I get y plus 1 is equal to 6x minus 6. And then I subtract 1 on both sides. I get y equals 6x minus 7. So that's the equation of my tangent line at that point. Now we have to find the equation of the normal line. So what's the one thing that's going to change in my calculation? Which is now going to be -1/6. Do y'all remember about the opposite reciprocal rule and all that? Okay. So we end up with y plus 1 equals -1/6 x plus 1/6. And then I subtract 1 on both sides, which gives me y equals -1/6 x plus, or minus, sorry, 5/6, right?
What?
1/6 minus 1.
Oh, I see.
Yeah, so if you need to like do it off to the side too, that works. So this is the equation of my tangent and my normal line. Now, you're going to notice it talks about graphing with Desmos. You guys are going to do that at the end of the notes on your own. So what you're going to graph on Desmos, you're going to graph the tangent line, the normal line, and the original function, and you're going to see how they look compared to each other, so you get an understanding of what's actually happening. If you graph the point as well, you can see where everything happens. So you guys are going to try that part on your own at the end. Does anyone have any questions about this one? This type of question, you will for sure have one of these on your test. Alright, so sometimes you're going to deal with these type of problems where you're dealing with trigonometry, right? So step 1 is we want to find the slope of a line tangent to. So we know right away, tangent to, we're trying to find the slope, so we know we need to take the derivative, okay? Because we know slope and derivative have that relationship. So we're going to start by taking the derivative, but before we take the derivative, we have to rewrite it in a way. Can you get him a note? Thanks. We have to rewrite it in a way that we put the power on the outside. So you see how it says sine and has the fifth power? You want to put that on the outside. You have to do this for Desmos as well because it won't accept the power there, so just keep that in mind. Now I have it defined inside and outside. Now what you're going to notice, there's an outside, there's an inside, and then there's a super inside, right? There's that inside. So that's going to mean we're going to have to do the chain rule twice. You remember doing that before break? So we're going to start by doing the chain rule once. We're going to bring the 5 out front, keep the inside the same, and then we're going to reduce the power by 1. So it's going to be to the 4th. Now we're going to take the derivative of the first inside. So what's the derivative of sine of 2x? Cosine of 2x. And then I have to do the inside. What's the derivative of 2x? 2. So if we simplify this down, we end up with 10 times sine of 2x to the power of 4 times cosine of 2x. So it wants to know at the point where x equals pi over 6. So we're now going to plug pi over 6 in for x. So we get 10 times sine 2 pi over 6 all to the 4th power times cosine 2 pi over 6, like that. What is 2 pi over 6 reduced to? Pi over 3. What's the degree equivalent of pi over 3?
30 degrees?
60. So those are exact values, right, from the unit circle. So, what is sine of 60 degrees? Anyone remember what that is?
What?
Sine of 60?
Square root 2 over 2?
Square root 3 over 2.
Good, square root 3 over 2. 2 over 2 is 45. Square root 2 over 2.
I forgot sine question.
That's okay. And then, what's cosine of 60?
1/2.
1/2, good. So that gives me y prime equals 10 times square root of 3 to the 4th would be 3 times 3, which is 9, over 2 to the 4th, which is 16, times 1/2, which this cancels and gives me 45 over 16. So this is my slope, right? So go back and read the question, make sure we've answered it. Does it want us to find an equation in this question?
No.
No, just the slope. So if it did want us to find the equation, we'd have to go back to the original, plug x in, get the y, then we have a coordinate, then we got to do point slope. That would take a lot of space, right? So this question only asks for the slope. So what we know is at this point, the slope is this. So what I want you to do on Desmos, you're going to graph this equation, and you're going to look at the x value where pi over 6 exists. You can actually type this in. It will draw you a vertical line where that occurs. And then you can look and make sure that the slope looks to be about what that is. Okay, so that's what you guys are going to do on your own, okay? I'm going to go ahead and start handing out the homework while you guys start with the Desmos. I have a few extra computers if you need them, if you don't want to do it on your phone.